Welcome back. In this video, I'm going to show you how to use the data set that we made in the last video to train the network using CopyCat. CopyCat has a neural network inside it, and we can train this network, meaning that we can feed the data set of input and ground truth images into CopyCat, which will then learn to replicate the desired effect, so that the effect can later be applied to the entire sequence. CopyCat learns the best weights to make the input images look like the ground truth images and saves these out in a .cat file. So let's jump into the CopyCat properties and take a look at what they do. In the CopyCat tab, you can choose to use the local GPU for rendering, if it's available, rather than the CPU. And this is turned on by default because using the GPU is much faster than CPU. The data directory is the path where the .cat files and the context sheets are written to. So set that to your preferred location. The epochs is the number of times CopyCat processes the data set during the training. Increasing this number often produces better results, but it will have longer processing times. More epochs will give the model longer to train, but it's possible that earlier cat files will produce better results. Knowing how many epochs to use will take some experimentation. For example, you may want to start with 10,000 and see what your result looks like before increasing the value to achieve a more effective model. You can stop and resume the training at any point if you want to see how the model is performing. I'll go into more detail about monitoring the training and adjusting the knob values later in this video. Next, you have some information telling you what channels are being processed from the input and ground truth. The channels in the upstream pipes are chosen automatically. So in my case, the input is RGB and the ground truth is just the red channel, as I removed the others. You can also see the batch size, which is the number of image pairs to train the network with at each step, and this is used to calculate the total steps, which is the number of epochs multiplied by the dataset and divided by the batch size. You can manually reduce the batch size in the advanced options by setting it to manual and entering a value. I'm going to leave it as it is on auto. If your auto batch size is smaller than you'd like, you can use the manual option to increase it to speed up your training and improve your results. Something to remember is that if you change the number of channels or the number of inputs with the CopyCat properties open, you will need to close and reopen the properties, otherwise the information knob will not be updated. So next, there's buttons to start and resume the training. I'm not going to press anything just yet, as I just want to run through the rest of the options first. So back to the advanced options. The initial weights lets you set whether the training should begin from scratch or from weighting defined by a previous model. If this is the first time you're training the network, you can leave this at none. Otherwise, you can choose to use a previously trained cat file, which will be saved in your specified data directory. The model size and crop size options are trade-offs between speed and quality. Increasing the values could cause you to run out of memory, so some experimentation with these is probably required. Small models are faster to train and use the least GPU memory, but large models may produce better results. The crop size defines the size of the random crops taken from the dataset image pairs. Large values may produce more accurate results depending on your image resolution, but at the expense of processing time and memory. Have a play around with these settings to find out what works best for your machine. If your training's taken a long time, you can try reducing the crop and model sizes, as well as the batch size, depending on what task you're performing. You can use the checkpoint interval and context sheet interval options to determine how often CAT and PNG files are written to the data directory. For example, a total steps value of 5,000 and a checkpoint interval of 1,000 would produce 5 CAT files over the course of the training. I'm going to leave all the options at their default values for now, but in the next video I'll show you some examples with varying options. So once you're happy with the options that you've set, you can start the training and take a look at the Graphs tab. Using the Graphs tab, you can view the training progress represented as a graph of step against loss. The steps are the total number of steps that the training needs to complete, and the loss is the value of the difference between the ground truth and the image that the network will produce at the end of that step. It's really important to monitor the training as it progresses to ensure that you achieve the best results and to make sure that nothing is going wrong. So as the training progresses, you'll see the graph steadily decline towards 0 on the loss axis. You can use the smoothness slider to get an idea of the general trend of the graph. When your graph appears to be flattening off, you can use the log scale option to see more detail at lower loss values. If your graph is going up or staying flat at this point, then it means you have an issue with your setup. As mentioned in the previous video, if you are using 2 append clip nodes, then you must make sure that the input order is the same for the input and the ground truth images. If this isn't the issue, then you may need to increase your model or your crop size for better results. If you have a look in the viewer, you'll see a crop overlay grid. And these can be a really good way of quickly spotting any obvious mistakes with your setup. For example, if the input and ground truth images don't line up, then it means that they have not been inputted to the append clip node in the correct order. This won't be an issue for me as I only have one append clip node. You can also use the crop overlay to see how the network behaves on certain frames. The size of the crops are specific to the crop size, which is why increasing the crop size in the properties can produce better results, but can take longer to process. The input and ground truth are the images from a dataset that we input into the CopyCat node, and the output is the effect that the network has learned so far applied to the source image. So over time, as the training progresses, you'll be able to see the output images change from random garbage matting in the first steps to replicate the ground truth later on. So don't worry if the first outputs don't appear as expected. This overlay is saved to the data directory as a PNG according to the contact sheet interval. So every 100 steps by default. The graph and contact sheet are designed to be used together, so don't worry if the contact sheet results are not perfect. As long as the graph trends towards 0, then your training should be going as expected. You can also use the preview input on the CopyCat node to view the training progression in the viewer. You can use this to see what the training looks like on frames outside of the dataset and potentially spot if there are any big issues. You don't have to use this input. By default, a PNG preview file is saved out to your data directory every 1000 steps, and you can change this using the checkpoint interval. If your graph is trending towards 0, but the output column is still not replicating the ground truth, then you can try increasing the number of epochs in the run. You also may need to add more image pairs to your dataset and make sure you really do have a diverse selection of images, as this tends to produce the best results. And as I said in the previous video, the more frames you use, the better your results are likely to be. I'm going to stop this video here and let the training finish. And in the next video, I'm going to show you how to apply the results from the training and make improvements.